the note sheet that we did in class yesterday, right? So you were supposed to do the evens on the worksheet, right?
Yeah.
Any problems with those? Which one? Number 6. Hey, number 6, don't throw things in my classroom. Number 6 is actually students wanted to do all kinds of stuff here. And I'm not sure why. The only thing you have to do here before you start combining like terms is distribute the negative sign on the last binomial. Everything else stays the same. I have negative 2x plus 3x squared plus negative 2x squared plus 5x cubed plus 5x, and then distribute the negative sign. You get negative 7x squared plus x. Then go through and start combining like terms. Let's see. 3x squared.
No.
3x squared minus 2x squared is 1x squared minus 7x squared is a minus 8x squared. I see what you're saying. Here's my 5x cubed. All right, what else we got? Yes, they have to be in standard order. Here's my negative 2x. I got a positive 5x and a plus 1x. That is 4x. And did I get everyone? And that's my answer. Easy peasy. I wouldn't take off for that. Any others? Okay, let's go back to the notes then. As if page 1 wasn't fun enough, flip it over to page 2. And we got some funner stuff going on here, man. We got some real fun stuff going on here. Now, back in last semester when we were factoring, we did work with one of these shortcut formulas. It was called the difference of squares, right? Where we had the product form a squared minus b squared. We had a shortcut to go to directly to the factored form, right? Anybody remember what that was? A plus b, a minus b. Okay, what? This is yesterday's. Okay, now we were factoring binomials last semester. This semester, we're going to not only factor, but we're going to go the other way, multiply the factors out. Which is what you kind of did yesterday for your homework, right? You're multiplying binomial times binomial and a binomial times the trinomial, and I showed you the box method, right? You were actually multiplying out the factors. We're going the other way. So, they gave us some shortcut formulas, or they're called special product patterns, or where we have a plus b, a minus b is the one I just showed. It turns out to be a squared minus b squared. Now, I normally don't teach these because you can always multiply things out either using FOIL or any of the methods I showed you yesterday, right? But they kind of come in handy when you're multiplying the cubes, like number 7 here. That's a cube polynomial. And it got to be quite a bit of work. Same with 8, didn't it? kind of got to be quite a bit of work. Well, we do have some pattern formulas or special formulas that we can go directly from the factored form, a plus b cubed, and go directly to the product form. So they start out by showing us, we're going to start out by using quadratic patterns. Then we'll go into the cube patterns because it's confusing. Yeah, but I don't know how. It's just quicker for me to do it in my head. Okay. It always was. Calculators weren't invented for me until after I was out of high school. So it's just easier for me to use my head. Okay, so for instance, number 11, then you should know, right? What's my A here? X. And my B? 7. I know, it's just really annoying. So my A plus B, A minus B happens to be A squared, which is X squared, minus, because there's a plus and a minus, 49, my B squared. That's my factor form, right? You guys should be used to that. We used it quite a bit last semester. Okay, number 9, however, this is not A plus B or A minus B. This is A plus B times A plus B. So we're going to look up here and notice that the 2 is outside the quantity. It's not with the variables. So we have to use this formula here. Okay. So what's my A here? And no, just X. It's the base. And what's my B? 2. And I'm just going to substitute it into my formula here. You guys see this? Okay. So I have equals A squared. So my A is X. So I have X squared plus 2 times my A, which is X, times my B, which is 2. And then I have plus B squared, so plus B squared. Then all I have to do is just finish this and simplify, right? X squared. Now, this is hard because we're not used to it, but you can always FOIL this. And again, the reason why we're doing this with quadratic is because we want to get used to it before we start hitting the cube. Bless you, my son. You're welcome. All right, number 10. What's my A? What's my B? It would be, except we're just going to use 4. The minus sign is going to tell us which formula to use. See, the bottom one's minus. That's where we're going to use the minus sign. But the base itself is 4. Okay, so I have A squared. What's my A? I have to square this. How am I going to square 3x? It's 9x squared, right? Because we're squaring the term. Okay, so this is actually 3 squared, which is 9x squared. Be careful with that, okay? You have to square the coefficients as well. All right, minus 2 times A, which is 3x, times B, which is 4, plus B, which is 4 squared. Six x. Oh, I'm sorry, you're right. 24x. 24x plus 16. Good, Greg. Well, we kind of simplified. There's nothing more we can do, can we? Can't combine any more terms. I really, I'm gonna like find a way to turn that off by the end of the semester. Okay, now things start getting a little funner, more funner. Okay, number 12. What's my A? X. What's my B? 3. Okay, this is x plus 3, the quantity cubed. So I'm going to use this top one here. So my first term, A cubed. My A is x cubed plus 3 times, so plus 3 times A squared, x squared times B 3, because my A is squared here. See my A squared in the formula? My A is x, so it has to be x squared. Got it? Okay, plus 3 times A is x, and my times B squared, which is 3 squared, plus B cubed. Okay, so we got x cubed plus 9x squared, good, plus, what is it? Well, 3 squared is 9 times 3, 27x. Yeah, I'm not done. 3 cubed is 27, right? Did I miss anything? They're screwed up? Got it? Some of you know this because, you know, playing on your phones. I don't know how you can, like, understand this and follow this when you're on your phones. Probably. All right, number 13, what's my A? What's my A? Good. What's my B?
5.
Yep. Okay, so this is a minus. I have to use the bottom one. No. Okay, so I have A cubed. My A, again, it's 2x is my A. I have to cube the number in the variable. Okay? Minus 3 times my A, which is 2x. And again, that has to be squared, so I have to square the number in the variable. Plus 3 times A, which is 2x, times B squared minus B cubed. Okay, 2 cubed, 8x cubed minus 2 squared is 4, 4 times 3 is 12x squared, plus, let's see, 5 squared is 25, times 2 is 50, 50 times 3 is 150, and don't forget your x. Did I? Ah, I did forget a 5, didn't I? Okay, yeah, I forgot a 5 because this one should be times a 5, right? Times a B. Okay, yep, you're right. Thank you. Thank you. It's, yeah, the opiates are still in my blood system. So 12 times 5 is 60, right? You know, that's funny because I did the same thing in my last class. All right, and then we got a minus 5 cubed, which is 5 times 5 times 5, which is 125. Thank you, Blake. Now, I told you this was getting fun, and this was more funner, right? Now, here's something you can do on a Saturday night. Get yourself a big bowl of popcorn and do these next two problems, right? Word problems. No. Okay, you ready? Are you ready, kids? Okay, number 14. From 1985 to 1995, the gross farm income G and the farm expense E in billions of dollars in the United States can be modeled by G equals negative 246 T squared plus 7.88 T plus 159, and the E equals 0.174 T squared plus 254 T plus 131, where T is the number of years since 1985. Write a model for the net farm income N for all these years. Got it?
How many points?
1 trillion million. All right, so it says we need to write a model for the net income. Now think back to your career day. What do they call this? Career development, where you go to work and you get this gross pay, right? Well, how do you get your net pay? The real money that you take home. Yeah, after your taxes. So your net pay equals your gross pay minus your taxes, or your, in this case, expenses, because taxes and expense. So now all we have to do is sub them into 2. Okay, we're looking for the net. My gross function is negative 0.246 T squared plus 7.88 T plus 159. That's my gross. And I have to subtract my expenses. Now, I have to subtract this total expense here. How am I going to represent that in my little new N function? Yeah, I have to have parentheses around it. Because what happens if you don't put parentheses around it? You'll get the wrong answer after all that work because you will not distribute the minus sign. Yes. Yeah, that would be, well, you're pushing a gray area there. All right, you need to distribute that minus sign. I told you, man, get yourself a big bowl of popcorn. This is fun stuff. 369. Okay, so my net function is going to equal negative 0.246 T squared plus 7.88 T plus 159 minus 0.174 T squared minus 2.54 T minus 131. And you talk about fun. There you go. And so what do you have to do next? That's right, my proud children. You're going to combine the like terms. let's see, negative 2.246 t squared minus 0.174 t squared. What do you get? Is that 4.2? 4.6? 4?
1.17.
No.
Oh, I didn't.
No. I think it's 4.2. Negative 4.2? Ah, maybe. Negative 0.72 t squared. No, that's not right.
No, I didn't.
No, that's not right.
0.42.
0.42, right? I could easily fix this. Okay, what about 7.88 t minus 2.54? It's going to be a positive 5.34 t, and then 159 minus 131, 828. And there's my net function. No, 1,000. Now, I challenge anybody to come up with something funner.
It wasn't that hard. Wait, is that one like?
Hey, let's do 15. Okay, if you're so interested. You're trying to raise money for your trip to Spain. You decide to sell cookies. The revenue from selling X cookies is given by the equation R of X equals 2.5X. The cost for making X cookies is given by the equation C of X equals X plus 32. What are you selling each cookie for? Look at your revenue function, because that's the money you bring in. If X is the number of cookies, here's your revenue function. What are you selling each cookie for? $2.50. $2.50 per cookie. Man, those must be some awesome cookies. Huh. Must be those funner cookies. All right, write a profit function. Again, your profit, thinking back to your career development days, is your revenues, right? All the money you take in, and you're going to subtract all of your expenses, or in this case, your costs. Okay, so your profit function is going to equal your revenue function, which is 2.5x. And I guarantee you, half of you are going to forget to do what? Parentheses. And your cost is x plus 32. So what does your profit function come out to be? 2.5x, distribute the minus sign, minus x minus 32. 2.5x minus 1x is 1.5x minus 32. There's your profit function. And they want to know, if you sell 381 cookies, what's your profit? So our x is going to equal 381. So all we have to do is plug that into our profit function. 1.5 times 381 minus 32 equals our profit. What's our profit, my children? 539. 539.50. Bigger than my paycheck.
Really?
If you count all the hours I spend at home, yes.
You get paid
Bi-weekly.